Hello everyone. In this example, we are going to make the phase diagram of AZ31 with strontium and calcium addition. So we are going to see the isothermal section where we are going to treat the strontium and calcium as inclusions. So let's start. So first we click on the phase diagram, wait for the window to open. Since we are going to have a different addition, so we are going to say no, and similar here we are going to say no to refresh our database selection. So we are going to select FT light since we have AZ31 and fact pairs for all the elemental composition elemental databases, and press OK. Now we are going to add our composition. So we have calcium, we have strontium, and here we will have our AZ31. And in FactSage, all the inputs are in molar formula. So if you have your alloy in, let's just say, weight percent, so you have to convert it to mole fraction. That's important. So we'll convert our AZ31 into mole fraction and add this here, which will be mg 0.96897, aluminum 0.027277, and zinc as 0.0037517. That will do it. Let's just press next. Okay, here we are going to select all the phases which we want in our phase diagram. Since I'm interested in exactly all the solutions, so we are just going to select, click on select all solution. It will select every solution. Similarly, we are going to select all the solids. If you want to change some of the solid, you can just right click here and see what type of selections has been made for you. So let's just say OK. Now we have to specify what type of phase diagram we want to make. Since we want to make an isothermal phase diagram, so we need to change our variable. To change our variable, you can double click on any of the section here. So let's just double click here. So we will have our phase diagram window. So yeah, we have two composition which are changing, that is calcium and strontium. So we'll just say next. Now here our temperature is not the y-axis, our temperature is constant. So we will click on this drop down menu and select constant and specify the temperature of our choice. For this example, let's select 300 degrees Celsius. Pressure, we are going to keep the constant at 1. Now we have a choice to change our x-axis and y-axis. Let's keep the x-axis as the same as given here. So the x-axis will be strontium as represented by the 1 here. You need to make sure that 1 or 0 are not the amount here. These are just on off switch, sort of on off switch. 0 means no, 1 means yes. So on x-axis we want strontium to change, so that's why strontium is 1, and we don't want any other compound to change, so they are 0. And we want strontium to have a range of 0 to 0.03. so just keep it that way. And similarly on the y-axis, this is constant, so we need to change. So click on the drop down menu, select y-axis, and the y-axis we want the calcium to change. So we say yes to calcium and switch off the strontium and put 0 here, and change the maximum amount to 0.03 because we are sort of treating them like inclusion. So we don't want the full range of the phase diagram, we want the short range where these are 0.03 maximum amount. So after we are done here, click OK. Now click calculate. Oh, sorry, it didn't click. Okay, now it's done. After clicking calculate, it will take 5 or to 10 minutes depending on your system. So let's wait for the result. And as usual, after the calculation is done, we have our phase diagram and we have bitmap properties which will define what will be the width and height of your diagram. So let's just press OK for the default option. OK again, and here we have our diagram. So what this shows here is we have AZ31 as the fixed amount, but we are including strontium and calcium as our inclusion, and we are looking at the very small section of the phase diagram at 300 degrees Celsius to figure out what will be the phases in this situation. And to label the phases, again go to the left portion. Here we have various modes, and you can select the stable phase label mode to label all the phases. So let's just click and see what type of phases we can see here. Okay, and let's click here. As you can see, you can label it and you can perform all different type of phase diagram isothermal sections. Thank you for listening.